Guys, is your Google Maps working? Mine thinks north is behind me.
Wait, hold up. This compass needle is just spinning.
Wait, why is there an aurora field in Singapore? That's not supposed to happen at the equator.
Hey guys, look at the news now.
Witnesses across Canada and northern Europe are reporting bright red and green auroras lighting up the night sky. Scientists believe that this may be linked to the sudden weakening of Earth's magnetic field. Authorities advise that global navigation systems may also be affected. More updates to come.
What is a magnetic reversal? It's when Earth's magnetic north and south poles swap places, meaning the entire magnetic field flips direction. This doesn't happen instantly. Instead, over tens to hundreds of thousands of years, the field weakens up to 90% and becomes unstable. The last major reversal happened about 780,000 years ago.
On to the impacts. Firstly, it changes the ionization charge in the atmosphere. Usually, less energetic cosmic rays are significantly deflected by Earth's magnetic field, so the equator receives more shielding from this particle bombardment. During a magnetic pole reversal, however, solar radiation at the equator surges. Furthermore, when ionization charge is disrupted, more cosmic rays are colliding with atmospheric molecules, and hence more ionized charged particles in the atmosphere. Lightning becomes easier to trigger and hence occurs more frequently. It can also interfere with our communication by affecting our GPS, which relies on precise signals from satellites orbiting the Earth's magnetic field. Increased radiation could damage satellite electronics and signal will become unpredictable, alongside the positional accuracy which would degrade. This also disrupts our television, internet, and phone services. Lastly, impact on biosphere. Many organisms use the geomagnetic field as a source of spatial information. It also protects them from harmful radiation. During magnetic pole reversal, magnetoreception in animals is disrupted. Navigation can be affected, especially for migratory animals, and behavioral changes such as burrowing or nocturnal activity will also occur.
So the main cause is actually the Earth's liquid outer core. And they are kind of turbulent and unpredictable, just like the hot miso soup. So at first, the molten iron circulates spontaneously in the liquid outer core. This irregular convection disrupts the usual magnetic pattern, weakening the main dipole. When the field stability drops below a critical threshold, or what we call the tipping point, the magnetic field collapses and the poles wander in all sorts of directions, and it flips to the opposite orientation. Eventually, the new magnetic field strengthens and settles, or if it doesn't, it snaps back into the old direction, known as an excursion.
Now I'll be talking about feedback loops. So the geodynamo is the process by which Earth generates its magnetic field, and it starts with molten metal flowing in the outer core generating electric currents. Then the currents produce the magnetic field, and lastly, the conductive material moved through the field influences molten flow in a way that can strengthen the currents. Now, to counter this effect, the Lorentz force opposes the relative motion of the magnetic field, and additionally, the Earth's heat energy is finite, and the temperature of the mantle can vary across the globe, so these are some of the factors that would limit the magnetic field. However, in the context of our movie idea, the following conceptualized positive feedback loop could occur. So first, the magnetic field will weaken, which causes more radiation to penetrate the atmosphere, which then increases atmospheric heating, and this altered surface temperature change the heat distribution of the Earth's surface and mantle. So these changes in heat flow through the mantle affects core convection, and if the heat flow becomes less stable, convection will weaken further, weakening the magnetic field even more. My airline app just sent an alert. Planes are being grounded because navigation systems aren't stable.
Wait, guys. What does this show GPS signal lost on my phone?
It will stop the reversal.
Alright, so this scenario is fictional, but magnetic field reversals are real. They have happened many times in Earth's history and life has always adapted. Understanding Earth's systems help us prepare for such global changes so we react with knowledge, not panic.
In reality, the magnetic pole reversals occur very slowly over tens to hundreds of thousands of years, unlike shown in the clip. This video clip is purely for storytelling and entertainment purposes.